Welcome to my channel. I'm Zhang Xu. Let's talk about the problem 22 at chapter 6. In this one, we need to find how far would you have to reach into the Earth to reach a point where your weight is reduced by 5%. So in this one, we can see this is the Earth and this is the position where you reach, right? So from the surface of the Earth to this orange circle. So the weight at the orange, we think it is F, and at the surface, of course, is mg. No problem. And then it tells us the force of gravity at the point inside this Earth depends only on the mass closer to the center than that point. So that means if we consider the gravity for this particle, we only need to consider the gravitational force caused by this orange circle. Do you agree? And this is proved in the textbook, and we don't prove it there. If you have the questions at this part, you can take a look at your textbook. And then we can see, so this weight is caused by the gravitational force by this orange circle. And then the weight at the surface of this Earth depends on the blue circle. Now, when we consider the gravitational force, we must know its radius, right? Very easy. For the orange one, the radius is r. For the blue one, the radius is the radius of the Earth. This is given. And also, we need to find the weight. So, to find the gravitational force, how can we find the weight? It's easy. We need to find the mass. So the mass for this orange circle is just the density times the volumes, right? And because this is a spherical, so the volumes is just the 3/4 and then pi r cubed. And similarly, the mass for the Earth is the density times the volumes. In this one, we can find the ratio for this mass in this equation. This one is given, and we put it there. We will use it later. As a cooker, we first thing cut the onions, right? So this is just a preparation work. The next one, we need to find the ratio for the weight, because they tell us the weight is reduced by 5%. So the weight at the orange one is there. It is G, gravitational force, the mass times the small mass r squared. And similarly, the weight at the surface of Earth is mg. It's just the capital G mass r m small m r Earth squared. There is no problem. So in this one, we can find the ratio for the weight. Do you agree? So ratio for the weight F inside this Earth is divided by the on the Earth mg is just equal to this one. So use this one divided by this one, we get this one. See, as this tells you, it's just 0.95. Why? Because it tells us it reduced 5%. So that means if the gravity on the surface is 100, and then it reduced 5, so it becomes 95. Do you agree? So then the ratio becomes 0.95. Now we input this equation inside, because there we know the ratio of the mass, and we input it inside. See, if we input it inside, we get only this term survive, and this term is the ratio of the radius, right, equals 0.95. And then the radius for this orange just equal to 0.95 times the radius for the Earth. Then we are done. So this is how we solve this problem. So when you solve the physics problem, sometimes it's like cooking. First thing, you need to cut meat, cut vegetables, and then you put all this in the cooks. This is how. So the first part is just to prepare the ratio for the mass, and because if we want to find the ratio for the weight, you must know the ratio of the mass and to replace it to the radius. And then after you input the numbers inside, you find yes, it is because it reduced 0.95, and then we must drive 0.05 about the Earth's radius, so it is 320 kilometers. Thank you.